Hi, students and friends. This is your host and teacher, Sayyid Ayazuddin Hadar, and you are watching Learn and Teach by Sir Ayaz. I'm continuing my past paper session, and this time I have selected IGCSE. It's of May, June 2024. Variant is 41. You know the code, which is 0620. It's paper 4, theory standard, and it's of 1 hour 15 minutes. You have to answer all the questions. You can use calculator in this paper. The total mark for this paper is 80. Periodic table is printed in question paper. So let's start the paper. Number 1. Name the process that is used to A. Convert sulfur dioxide into sulfur trioxide in the manufacture of sulfuric acid. This is something which you have to learn by heart. It's contact process. So write contact process. Part B. Obtain water from aqueous sodium chloride. Simply you will go for distillation. Distillation is a process in which you will get the liquid from the solution mixture. C. Extract aluminium from purified bauxite. The process uses electrolysis. D. Separate petroleum into useful substances. You know it's fractional distillation. So I will write fractional. Distillation. Part E. Produce ethanol from aqueous glucose. The process is fermentation. F. Manufacture alkenes and hydrogen from large alkane molecules. It's either catalytic or thermal cracking. Catalytic or thermal cracking. The process is cracking. G. Separate a mixture of soluble colored substances. We have chromatography. So write down chromatography. Number 2. Complete table 2.1. Here's table 2.1. We have atom or ion here. For Cl 37 and 17, the number of protons must be 17. Small number is the number of protons, 17. And for number of neutrons, you have to subtract proton number from nucleon number. 37 is the nucleon number. So 37 minus 17. You'll get 20. For Cu plus, look at the proton number in order to find the number of protons. It's 29. Write down 29. Plus mean it has lost 1 electron. So simply subtract 1 from 29. 29 minus 1. And we will get 28. 28 must be the number of electrons here. So what about the symbol for atom or ion? In case of the last one, we have information provided. Number of protons is 16. Number of electrons is 18. It's more than number of protons. In fact, it must be carrying -2 charge. So we have ion here. And the number of neutrons is 17. So let's find out the element with 16 as proton. Must be sulfur. See, 16 is the number of proton in sulfur. So you write S here. And I'm going to write 16. What about nucleon number? In order to find the nucleon number, you have to add number of protons and number of neutrons. 16 plus 17. So it will become 33. As you can see, there are 18 electrons, which means there are 2 more electrons. So you have to write -2 or 2 minus above sulfur. 2 minus or -2. Both are correct. Moving to next question. Question number 3. This question is about the elements sodium and fluorine and the compound sodium fluoride. A. Sodium reacts with fluorine to form sodium fluoride. Write a symbol equation for this reaction. Sodium belongs to group 1. Symbol for sodium is Na. Fluorine belongs to group 7. Symbol for fluorine is F. But you have to write F2 for fluorine because the group 7, they all exist as diatomic. All exist as diatomic molecule. So I will write Na plus F2. So formula for sodium fluoride. For sodium, the valency is +1. For fluorine, the valency is -1. So ignore the charges. +1, -1, 1, 1. Swap these values, these numbers. You will get NaF as the final formula for sodium fluoride, NaF. Now let's balance this reaction equation. Simply write 2 before Na and 2 before NaF. So this will be the final reaction equation for this one. Part B. Some properties of sodium, fluorine, and sodium fluoride are shown in table 3.1. It's table 3.1. You have sodium, fluorine, and sodium fluoride. Number 1, explain why sodium conducts electricity when it is a solid. Sodium is a metal, so it must be having delocalized or mobile electrons. Delocalized or mobile electrons. Part 2. Complete the dot and cross diagram in figure 3.1 of a molecule of fluorine. Show outer shell electrons only. So fluorine belongs to group 7, which means it's having 7 valence electrons. So both the fluorine atom needing 1 electron to complete their valence shell. So I'm going to show 7 electrons for each of these fluorine atom with 1 electron shared between coming from each fluorine atom. For the right hand side, I'm using cross 1, 2, 3, 4, 5, 6, 7. For the left hand side, 1, 2, 2, 3, 4, 5, 6, 7. So this will be the final dot and cross diagram for fluorine molecule. Number 3, reduce the physical state of fluorine at -200 degrees centigrade. Use the data in table 3.1 to explain your answer. So they are asking about fluorine at -200 degrees centigrade. If you look at fluorine, the melting point is -220 and boiling point is -188. So it must be in the liquid state because -200 is between -220 and -188. So physical state must be liquid. Now what you will do, refer for explanation, refer melting point, melting and boiling point. Write down the melting point and boiling point. Part 4. Explain in terms of structure and bonding why sodium fluoride has a much higher melting point than fluorine. Sodium fluoride is NaF and fluorine is F2. So for structure and bonding, you can either refer to the structure and bonding in sodium fluoride or in fluorine. Refer structure and bonding either in NaF or F2. For example, if you are referring for NAF, what you're going to write for the structure? It's giant ionic lattice. Giant ionic lattice. And for bonding, what you will write? Strong electrostatic force. Strong electrostatic force between positive and negative ions. Between positive and negative ions. You can either write this or reverse argument. They are saying or reverse argument, it means you can write it for fluorine, which is F2. F2, the structure must be simple molecule. Must be simple molecule. So the bonding, weaker attraction. As you are saying stronger attraction for the NAF, then here, there must be weaker attraction here. Weaker attraction. The C, dilute aqueous sodium fluoride undergoes electrolysis. Hydrogen is produced at the cathode. One, state what is meant by the term electrolysis. It's made up of two terms. We have electrolysis. Electro means electrical, electricity. Lysis means breakdown. So here you will write what? What do you write? You will write breakdown of ionic substance in molten or aqueous state. In molten or aqueous state. How it's happening? Through the passage of current. Through the passage of current. Now part 2, write an ionic half equation for the production of hydrogen at the cathode. You have one common reaction, that the formation of hydrogen gas at cathode. It involves reduction. It's gaining 2 electrons by hydrogen ion, which is positive ion here. So you'll get hydrogen gas. I'm going to show the state symbols also. Hydrogen ion must be aqueous and hydrogen gas G. 4, hydrogen iodide thermally decomposes into iodine and hydrogen. The reaction is reversible. Here's the reaction equation, 2HIG, which means gas, reversible sign I2G plus H2G. Figure 4.1 shows a gas syringe containing a mixture of hydrogen iodide, iodine, and hydrogen gases. The gas syringe is sealed and the mixture is heated to 300 degrees centigrade. The mixture of gases reaches equilibrium and is purple. A, state what is meant by the term equilibrium. Now they are asking the meaning of the term equilibrium. So remember, you have to refer both forward and backward reactions, rate of reactions, refer rate of reactions in both direction. And this is when I'm saying referring rate of reaction both directions, so you'll write rate of forward reaction, rate of forward reaction equals the rate of backward reaction, backward or reverse reaction. but you can't get full marks for this. You will get only 1 mark for this. Then you have to refer the second statement, which is related to the concentration of reactants and products. Now refer concentration of reactants and products. So what you're going to write, concentrations of reactants and products are no longer changing. Next part, part B, the pressure of the mixture is increased. All other conditions stay the same. The position of equilibrium does not change. The color of the gaseous mixture turns darker purple. Temperature remains constant. So if you are increasing the pressure, what will happen? The equilibrium will shift to the side with less number of moles, but here you have same number of moles or molecules or volume of gases on both sides. So part 1, explain why the position of equilibrium does not change. This is the reason it's not changing, because you are having same number of moles, molecules or volume of gases on both sides of the equilibrium. Same number of moles, molecules, volumes of gases on both sides of equilibrium. Part 2 suggests why the color of the mixture of gases turns darker purple. So this must be due to the reason that iodine, you have same number of iodine particles or molecule in a smaller volume, because if you increase the pressure, the volume will decrease. So you can write the statement, increasing pressure decreases the volume of gases. Increasing pressure decreases the volume of gases. So as they are same number of moles, volume, or molecules of gas on both sides of the equation, and we have only iodine as the only purple colored gas here, there will be same number of iodine particles or molecules in a smaller volume. There will be same number of iodine particles in a smaller volume. Moving to next part C. The temperature of the mixture of gases is decreased. All other conditions stay the same. The mixture of gases turns lighter purple. State what can be deduced about the forward reaction from this information. So it's turning lighter purple. Decreasing temperature shift the equilibrium on the left hand side. Lighter purple means it will definitely move to the left hand side, which is reactant. So it must be exothermic. This side must be exothermic. So if backward direction is exothermic, the forward direction must be endothermic. So it must be endothermic. So you write endothermic. Simply the answer must be endothermic. Remember, they are talking about forward direction. So endothermic in the forward direction. D. Reduce oxidation number of iodine I in HI. Hydrogen. Whenever hydrogen is attached to non-metal, it must be carrying plus charge. So iodine must be carrying minus charge, which is the oxidation number of iodine here. So you write -1. In I2, it must be 0, as there is no charge on I2.